Alright, so we're going to start with sequences and series. The first thing that I want to talk about is I want to talk about what they are, okay? And then do some introductions, working with them, kind of a thing, seeing the patterns that they produce, etc. There are three different kinds of sequences and series. There's arithmetic, which is where we add, okay, or subtract to get the next term. There's geometric, which is where we multiply to get the next term, or divide. And then there's infinite ones, okay, on both cases. Okay? So we'll spend about a week dealing with each of those, okay? And then we will have the test then at the right before spring break. Okay? So this is on page 794 in your textbook. If you don't want to write all this down, or you want to rewrite it down and you miss something or something like that, okay? You've seen sequences and series before. You did a whole unit on them in Algebra 2. Okay? Okay? So this is, again, not a fresh, new, brand new, never seen before concept, but you haven't seen it probably in some time. Okay? So a sequence is a list of patterned numbers. So it's not just random numbers thrown in a list. There's a specific order, there's a specific pattern that holds for every number within that list. Okay? I'm not worried about the domain and the range of a sequence or a series. Just know that the third number that comes in your list, that is called the third term. Okay? One way to denote that is with subscript. So you could say A sub 3 is the third term. A sub 92 is the 92nd term in that particular pattern. Okay? Each individual one, each individual number is called a term. There are two different kinds of sequences. There's finite sequences, which are sequences that have an end value to them. Okay? So they can look like this. First off, a sequence, the terms are separated by commas. Okay? So 2, 4, 6, 8 is a sequence. We could also write that as and pick a number, and that number is where it ends then. So this pattern continues. These three dots right here tell me that that pattern is going to continue until we get to 32, and 32 is our ending term then. Still a finite sequence. It has an ending, limited amount. An infinite sequence goes on forever and ever and ever and never ends. And it is signified by the three dots as the last thing. The three dots signify that that pattern continues. Okay? In a finite sequence, that pattern continues until you get to a point. In an infinite case, the pattern continues forever and ever and ever. Sequences are usually defined by a specific expression, meaning that there's a rule or a pattern that goes along to it. In these particular two infinite and finite sequences, the pattern was 2n. Okay? If you take the term number, multiply it by 2, that gives you the value of that term. Okay? The rule is your pattern. Okay? Usually we'll write it in equation form, but I will also accept it in expression form. Questions on sequences and series? As we are learning and as we're starting here in the intro, one of the very first things that the book likes to do, I like to do, is just get into finding the first few terms of a sequence. Okay? So it says write the first 6 terms of the following sequences. Okay? Well, the first term, I'm going to take the number 1 and I'm going to put it into my rule in place of the variable that I have in that particular one. In this particular rule, the variable is n, so I'm going to replace n with 1 because it's the first term. Okay. 2 times 1 is 2, plus 5 is 7. So my first term is 7. Now, I don't know how good you are with numbers, but it's very hard to find a pattern based off of one number. Okay? One might say it's impossible because there's infinite amount of patterns that can happen off of just one number. Okay? So we've got to go to a second term. Again, I would take now 2 and I would plug 2 into my rule. 2 times 2 is 4, plus 5 is 9. Okay. Again, there's still a lot of patterns going on between just 2 numbers, so let's go to a third. Two times 3 plus 5 is 11. Now we can see a pretty distinct pattern developing. Okay? Adding 2, adding 2. So my fourth term should be what? 13. And if I would do 2 times 4 plus 5, I would get 13. Okay? Can't see the pattern unless you have 3 terms. I'll tell you that right now. Okay? Can't see the pattern unless you have 3 terms. So you got to do the math at least for the 3 in order to find the fourth, and in this case the fifth. Should be 15, and the sixth should be 17. Okay. Then, to give my final answer, because it said write the sequence, so I would start with my first term of 7, comma, 9, comma, 11, comma, 13, comma, 15, comma, 17. I needed to write the first 6 terms of the sequence. If I only wrote the first 5 terms, clearly I didn't follow directions. Okay? So if you don't get all the way to the 6th term, you're not done yet. as you're going to Milwaukee and you stop in Fond du Lac, you can't say, "Hello, Milwaukee." Oh.
Since you said only to do 6 turns, you don't do the dots then?
No, because it just said write the 6. Find me the first 6 terms in number 2. Oh, probably.
See ya.
Have a good day.
Will the notes be posted at 3?
I don't know, probably like in an hour.
Okay, thank you.
So what's that going to be? 1. No, it's going to be 1. Anything to the 0 power is 1. Appears to me that we are multiplying by -3 every time. So then my 4th term should be -27. My 5th term should be +81. And my 6th term should be -243. Yep. So then if I write these all out, it'd be 1, -3, 9, -27, 81, -243. Yes? Try number 4. We'll skip number 3. Oh, it's not that bad. Now, what if we didn't see the pattern that we added 1 to both the top and the bottom after putting in 3 times? What will we have to do? Just keep going with the plug 4 in, then plug 5 in. If you don't see the pattern right off the start, then just keep plugging stuff in.
What do you even say? Yeah, again, how do you expect me to respond?
Okay, so classic style of problem, which you'll probably see on a test, quiz, final. NTC likes these type of problems too, is written out here. So these would be the directions. Describe the pattern, write the next term, write the rule. Okay? Apparently mine. I don't know if somebody from the United States is calling me.
Better answer than
No.
government. I'm just kidding. They're all.
So this is broken out into 3 parts. So the first part describes the pattern. That's words. I know your math teacher is making you use words. Okay? So if I had to describe the pattern here, I would say that this pattern in number 5 is the negative cubes. Would you agree? 1 cubed is 1. Negative of it is negative 1. 2 cubed is 8. Negative 8. 3 cubed is 27. 4 cubed is 64. So then this next, write the next term is a find it. So you got to find, using the pattern, you got to find the next one. Actually, I shouldn't say find right there. We'll say next. So that would be negative of 5 cubed. Well, that's going to be negative 125 would be the next term. And then lastly it says, write the rule. Well, the rule comes out of your description, basically. Sometimes you got to do some maths to put that into mathematicalness, but the rule here would be negative n quantity cubed. Okay. Anybody see a pattern in number 6? So how can we say that in words? We say it like that? Does that make sense? Could we just say adding even numbers? Why not? It's not specific enough. Yeah, because this is going up, it's adding the next one every time, the next even every time. Okay? It's going up in a specific pattern. It's increasing. Okay? If that's the case, what's the next term? 20, yep. If that's the case, what's the rule? N plus 2? If I try that with my first term, right? So if I plug in 1 to your rule, 1 plus 2 is 3. My first term is not 3, so it fails on the first one. Okay? Because my rule has got to work for every single one of my terms.
1 plus
Hmm?
Wouldn't the first one be one, or the first and would be one?
Mm-hmm.
If we're adding the multiplier, can't add one to make it
You can add a negative number. Hmm? And so n minus 1 then, right? Okay, right, let's try it. First term, 1 minus 1. 0 works out. Second term, 2 minus 1. 1 doesn't work out. Okay? So this rule, and you might have to spend some time coming up with these rules, this rule is actually n squared minus n. Because if you think about it, first term, 1 squared is 1, minus 1 is 0. Second term, 2 squared is 4, minus 2 is 2. Third term, 3 squared is 9, minus 3 is 6. Fourth term, 4 squared is 16, minus 4 is 12. Fifth term, because we have the fifth term, is 20. 25 minus 5 is 20. Okay. Your rule can't just work on one term. Your rule has to work for all the terms. I'll say that again. The rule that you come up with has to work on all of your terms, not just one. Okay? Shift gears here now to series. The only difference between a sequence and a series is the sum of a sequence. If I had a sequence of 2, 4, 6, and 8, I would write it like that. Right? It's the sequence that we had. Second slide. The series of that same size would be written as 2 plus 4 plus 6 plus 8. No commas, addition signs instead. So if it were -2, -4, -6, and -8, but we could also write it as like that too. Because we don't really write plus negatives. Okay? Sigma notation is the other big concept when it comes to series. Okay? So let's break down sigma notation again. Sigma is that wonderful looking Greek letter. Okay? You will have some kind of variable. You've got 26 to choose from. Whatever variable you have defined there should be the variable that you have in the rule that you come up with then. So if you choose n, n is in your rule. If you choose q, your rule would be in terms of q. All right? You're going to have some number that this is equal to down here. That's going to be the starting value that you plug into your rule. You're going to have an ending value up here. You're going to plug in each integer from your start until your end into your rule. Okay? Now, with that being said, if it's an infinite sequence or series, then this can be infinity. If it's infinite. And then out here, you're going to have the rule that we're talking about. Let's try some. Okay. So we know we're going to have sigma. First, we need to pick a variable. What you got? B. Okay. What do you got? B equals 25. Okay. Before we do that, let's figure out what our pattern is first. Adding by 25. So then what would my rule be? B plus 25? If B plus 25 is my rule, my first term should be 26. My second term should be 27. My third term should be 28. Because I plugged in 1. If my rule is B plus 25, if I plug 1 in there, I get 26. If I plug 2 in there, I get 27. 25 times B? Do we agree with 25 times B? If my rule is 25B, what's the number that I start with? If I plug 25 into my rule, I get 625. What's the number I start with? 1. What's the number that I end with? If I plug 250 into my rule, I get 6,250. What does? 10. Again, these are things that you should be making sure of every single time. Your rule has to fit your pattern. Okay? Plug in certain numbers to get the pattern. Okay? Sigma notation. Variable. Q. Pattern. N over N plus 1? Or?
Q.
Over?
Q.
That's my pattern. That's my rule. Where do I start? Where do I end? What's wrong? Okay. Let's go back the other way. I want to find the sum because it's summation notation has that in it. Sum. We need to find the sum. So I need to find the first term. Well, I'm going to take my starting value here and I'm going to plug it into my rule. 8 times 1 is 8. Then I'm going to find my second term. I'm going to plug in 2 into my rule. I get 16. I'm going to find my third term. 8 times 3, 24. My fourth term, 8 times 4, which is 32. My fifth term is going to be 8 times 5, which is 40. Do I need to find my sixth term? Why not? 5 signifies where I stop, right? Summation says I have to add all of these numbers together. And I get 120. Pay attention to your rule and your start, because on this particular one, my first term is 3 squared minus 1, which is 8. Four squared minus 1 is 15. Do I need to go on? Why not? Why or why not? Why? So I got to go to 7 terms? Everybody agree that I got to go to 7 terms? Sam, talk to me. Why? It says go to 7. Did I go to 7? Yes, I went to 7. Okay? It says stop when you've plugged in 7. I plugged in 7. Okay? So then I would just have to find the sum of those. $130. Okay? No formative tomorrow. However, there is some homework for Wednesday.